inverse relations and functions. Let's start with the definition. The inverse of the relation consisting of all ordered pairs x comma y is the set of all ordered pairs y comma x. The graph of an inverse relation is the reflection of the graph of the relation across the line y equals x. In this lesson, we're going to determine inverse relations using three different methods. First, we will rewrite ordered pairs. Secondly, we will reflect relations across the line y equals x. And finally, we will rewrite functions in order to graph inverse functions. In rewriting ordered pairs, what we do is simply reverse the order in each ordered pair. In this ordered pair, the value of -2 for x becomes the value of -2 for y. Also, the value of 0.25 for y becomes the value of 0.25 for x. The same process is repeated for all coordinate pairs, so they are all inverted. The relation represented by the coordinates in red is the inverse of the relation or function of the coordinates in blue. Now we'll do the same thing, but from coordinates in a table. Here's a table of data, the same data we looked at earlier, but in table form. Here's that first coordinate pair with the x and y coordinates switched. And here's the table on the right with all points in the original table switched. So that's how we can do it from rewritten ordered pairs, from the ordered pairs themselves, or from a table. And here's the same relation, but graphed as opposed to using ordered pairs. And here's the function y equals x. Here we're going to apply the principle that the graph of an inverse relation is the reflection of the graph of the relation across the line y equals x, and that's the line y equals x in blue. So we can draw each point as a reflection across that line, the function y equals x. Here are the first three reflected points drawn in quadrant 4. And here are the other 3 points in quadrant 1. And here's the curve drawn over the points. These functions are inverses of each other because they reflect across the line y equals x. So that was our second method mentioned at the beginning, reflecting across the line of the function y equals x. The final way we'll look at is by manipulating the function to change it to an inverse of the original function. We'll start with this function, f of x equals 2x plus 3. The first thing we'll do is change the equation so that we have y equals 2x plus 3 instead of f of x equals 2x plus 3. To change it to an inverse function, we switch locations of x and y. Next, we'll employ the symmetric property of equality and rewrite the equation as 2y plus 3 equals x. So that's just flipping the equation about the equal sign. Now we set about solving for y by subtracting 3 from both sides of the equation. 3 minus 3 cancel on the left side. We bring down what's left. 2y equals x minus 3. Next, we solve for y by dividing all terms by 2 rather. 2 divided by 2 cancel on the left side. We bring down what's left. Solve for y. We have y equals 1/2 x minus 3 over 2, which I decimalized to become 0.5x minus 1.5. Now we'll put the first equation into the calculator, and here it